Tankless water heaters are typically considered non-continuous loads because they only draw significant power when hot water is being used. National Electrical Codes, commonly known as NEC, considers loads that operate for more than 3 hours to be continuous. Since tankless water heaters operate intermittently, they fall under the category of non-continuous loads. Load calculations for existing installations apply differently than for new construction. In new construction, the entire service capacity is typically determined based on the calculated load. For existing installations, the existing capacity is used as a starting point, and additional loads are added as needed. However, if the existing service is inadequate to handle the additional load, a service upgrade may be necessary. It is not advisable to agree to wait for the main breaker to trip before proceeding with a service upgrade. Overloading the service can lead to dangerous situations, including overheating, insulation damage, and potential fire hazards. It is essential to ensure that the service capacity is adequate before connecting the tankless water heaters. Here's a recommended approach. Firstly, calculate the existing load on the electrical service. Secondly, add the amperage draw of the tankless water heaters, in this case 116.8 amps. Thirdly, compare the total load to the existing service capacity. Fourthly, if the total load exceeds the service capacity, a service upgrade will be necessary. Fifthly, inform the customer of the potential service upgrade requirement and explain the safety risks associated with overloading the service. Sixthly, do not proceed with the installation of the tankless water heaters until the service upgrade is complete. When evaluating the electrical load of a tankless water heater, it's crucial to differentiate between continuous and non-continuous loads according to the National Electrical Code, or NEC. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. For continuous loads, the circuit breaker and conductors must be rated for 125% of the continuous load current. A non-continuous load is one where the current is not expected to last for 3 hours or more. Tankless water heaters typically fall into the non-continuous load category because they only draw significant current when hot water is actively being used. However, it's essential to consider the specific usage patterns in a particular installation. If a tankless water heater is expected to operate for extended periods, it might be more prudent to treat it as a continuous load for safety and compliance purposes. Calculating electrical loads in existing installations differs from new installations. In new construction, the electrical service is designed and sized based on the total calculated load of all expected appliances and devices. This ensures that the service has sufficient capacity from the outset. In existing installations, the starting point is the existing service capacity. The load calculation process involves determining the existing load, adding the new load, in this case, the tankless water heaters, and comparing the total to the existing service capacity. The existing load can be determined by examining historical energy consumption data, conducting a load study using a clamp meter, or referring to previous electrical inspections or documentation. The new load, which is the tankless water heaters, must be accurately calculated. The amperage draw of each tankless water heater should be obtained from the manufacturer's specifications, usually found on the nameplate of the unit. It's crucial to consider the voltage at which the water heater operates, typically 208 volts, 240 volts, or 277 volts, to ensure the amperage calculation is accurate. For example, a 28 kilowatt tankless water heater operating at 240 volts will draw approximately 116.8 amps, as indicated earlier. Once the existing and new loads are determined, they are added together to find the total load. This total load is then compared to the existing service capacity, which is determined by the size of the main breaker or the service entrance conductors. If the total load exceeds 80% of the service capacity, it's a strong indication that a service upgrade is necessary. This 80% threshold is a common rule of thumb to prevent overloading and ensure safe operation. The consequences of overloading an electrical service can be severe. Overloading can cause the conductors to overheat, leading to insulation damage, premature aging of electrical components, and increased risk of electrical fires. Additionally, overloaded circuits can cause a nuisance tripping of circuit breakers, disrupting electrical service and potentially damaging sensitive electronic equipment. Allowing a customer to wait for the main breaker to trip before committing to a service upgrade is generally not advisable for several important reasons. Firstly, waiting for a breaker to trip indicates that the electrical system is already being overloaded, which is a dangerous condition. Continuous overloading can degrade the insulation on conductors, increasing the risk of short circuits and electrical fires. Secondly, relying on the breaker to trip as a means of preventing damage is not a reliable or safe approach. Circuit breakers are designed to protect against overcurrents and short circuits, but they are not intended to be used as a primary means of managing load capacity. Repeated tripping of a breaker can weaken its internal mechanism, reducing its effectiveness and potentially leading to failure. Thirdly, overloading an electrical system can have implications for insurance coverage. If an electrical fire or other damage occurs due to overloading, the insurance company may deny coverage if it's determined that the homeowner or contractor was aware of the overloading condition and failed to take corrective action. It is always best practice to proactively address potential overloading issues by performing accurate load calculations and taking appropriate steps to ensure that the electrical service has adequate capacity for the intended loads. Here are more detailed steps and considerations for calculating the electrical load and determining the need for a service upgrade. Firstly, gather information about the existing electrical service. Determine the size of the main service breaker, typically found in the main electrical panel. This will indicate the maximum amperage the service is designed to handle. Also, identify the size and type of service entrance conductors, as these conductors must be adequately sized to carry the load. Secondly, determine the existing load. There are several methods to determine the existing load. One approach is to review historical energy consumption data from utility bills. This data can provide insight into the average and peak demand of the household. Another approach is to conduct a load study using a clamp meter. A clamp meter can measure the current flowing through the service entrance conductors at various times of the day to determine the maximum demand. A third approach is to review existing electrical documentation, such as previous electrical inspections or permits, which may contain information about the existing load. When calculating the existing load, it's important to account for all significant electrical appliances and devices in the home. This includes lighting, heating and cooling systems, refrigerators, ovens, dishwashers, washing machines, dryers, and any other major appliances. Each appliance should be listed with its wattage or amperage rating. For appliances with motors, such as refrigerators and air conditioners, it's important to consider the starting current, which can be significantly higher than the running current. The starting current is typically listed on the appliance's nameplate. Thirdly, calculate the new load, the tankless water heaters. Obtain the manufacturer's specifications for each tankless water heater, including the voltage, wattage, and amperage ratings. As mentioned earlier, a 28 kilowatt tankless water heater operating at 240 volts will draw approximately 116.8 amps. Ensure that the amperage rating is consistent with the voltage available at the installation site. Fourthly, apply demand factors. Demand factors are used to account for the fact that not all electrical appliances and devices will be operating simultaneously at their maximum load. The National Electrical Code, Article 220, provides guidelines for applying demand factors to various types of loads. For example, a demand factor of 100% is typically applied to heating and cooling loads, while a demand factor of less than 100% may be applied to lighting and receptacle loads. Consult the NEC for specific demand factors based on the type of load and the number of appliances or devices. Fifthly, calculate the total load. Add the existing load and the new load, taking into account any applicable demand factors. This will give you the total calculated load for the electrical service. Sixthly, compare the total load to the service capacity. Compare the total calculated load to the existing service capacity, as determined by the size of the main breaker or the service entrance conductors. If the total load exceeds 80% of the service capacity, it's generally recommended to upgrade the service. This 80% threshold provides a safety margin to prevent overloading and ensure reliable operation. Seventhly, consider future expansion. When evaluating the need for a service upgrade, it's important to consider potential future electrical loads. If the homeowner plans to add additional appliances, devices, or electrical circuits in the future, it may be prudent to upgrade the service to accommodate these anticipated loads. Eighthly, consult with a qualified electrician. It's always recommended to consult with a qualified electrician to perform a thorough load calculation and assess the need for a service upgrade. A qualified electrician can accurately assess the existing electrical system, perform the necessary calculations, and provide recommendations for ensuring a safe and reliable electrical installation. Ninthly, document the load calculation. Keep a record of the load calculation, including all assumptions, demand factors, and calculations. This documentation can be helpful for future reference and for demonstrating compliance with electrical codes and regulations. Tenthly, obtain necessary permits and inspections. Before performing any electrical work, including a service upgrade, it's important to obtain the necessary permits from the local electrical authority. Electrical work must be performed in accordance with applicable electrical codes and regulations, and it must be inspected by a qualified electrical inspector to ensure compliance. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including service upgrades. Some relevant sections of the NEC include Article 220, which covers load calculations, Article 230, which covers service entrances, and Article 310, which covers conductor sizing. In addition to the NEC, local electrical codes and regulations may also apply. These local codes may have additional requirements or restrictions that must be followed. A service upgrade involves replacing the existing service entrance conductors, main breaker, and electrical panel with larger components to increase the service capacity. The size of the new service entrance conductors must be calculated based on the total calculated load, in accordance with NEC guidelines. The new main breaker must be sized to protect the service entrance conductors. The new electrical panel must have sufficient capacity to accommodate all existing and future circuits. A service upgrade may also involve upgrading the grounding system to ensure proper electrical safety. The grounding system must be installed in accordance with NEC guidelines. It is important to ensure that the new service entrance conductors, main breaker, and electrical panel are compatible with the existing electrical system. A qualified electrician can ensure that all components are properly sized and installed. A service upgrade can be a significant expense, but it's a necessary investment to ensure the safety and reliability of the electrical system. It's important to obtain multiple quotes from qualified electricians before proceeding with the work. In summary, determining the need for a service upgrade involves a comprehensive load calculation, consideration of potential future loads, and consultation with a qualified electrician. By following these steps and adhering to applicable electrical codes and regulations, you can ensure a safe and reliable electrical installation.